Breaking news out of Volusia County. We've been showing you severe erosion in Wilbur by the sea, and a home has collapsed into the ocean.
Beneath the turquoise waters off the coast of Florida, the unthinkable happened. The ocean floor, long thought of as a stable foundation of sand, rock, and ancient coral, suddenly gave way in a violent and dramatic collapse. Entire sections of seabed dropped into the abyss as sudden oceanic sinkholes opened, swallowing marine habitats and reshaping the underwater landscape in a matter of moments. What was once a level expanse of continental shelf fractured into gaping voids, with rims of jagged rock crumbling downward into dark hollows. The event sent shockwaves through the surrounding waters, displacing marine life and churning sediment into vast underwater clouds. This collapse was not gradual erosion or a slow, imperceptible shift. It was sudden, violent, and impossible to ignore. Before we start, smash the like and subscribe buttons for more updates. The Florida seabed has always been a unique geological puzzle. Much of it is made up of porous limestone and ancient reef systems, which over millennia have been shaped by the ceaseless work of water-carving caverns and channels below the surface. These hidden voids, often unnoticed, represent weak points within the crust beneath the shallow coastal seas. When the delicate balance of water pressure, rock integrity, and sediment load shifts too far, the overlying floor can no longer support itself. What emerges is the oceanic counterpart to sinkholes on land. Sudden collapses that open into yawning underwater chasms. The sheer scale of such features dwarfs terrestrial sinkholes, since the immense weight of water pressing down magnifies every structural weakness. The collapse of Florida's ocean floor reveals the quiet but powerful instability that has been building beneath the waves. As sections of the seabed fell away, enormous plumes of fine sediment were released, reducing visibility to near zero across wide stretches of ocean. Fish, turtles, and countless smaller organisms fled the disturbance, while coral colonies and seagrass beds were ripped apart and dragged down into the depths. For creatures accustomed to stable habitats, the sudden change created chaos. Entire micro-ecosystems that had thrived in balance for centuries vanished in seconds, consumed by the collapse. The event did not just reshape physical terrain, it disrupted the living fabric of the ocean itself. Oceanic sinkholes are not merely holes in the ground, they are complex geologic systems with their own hydrodynamics and chemical environments. As the seabed collapses, groundwater seeps in through exposed limestone channels, altering salinity, temperature, and nutrient levels. In Florida's case, the sinkholes may now act as conduits between the ocean and the vast aquifer systems that underlie the state. That connection raises questions about how saltwater intrusion might accelerate and how delicate freshwater reserves could become further compromised. Beneath the surface, invisible exchanges of water could be taking place, transforming the chemistry of both ocean and land in ways that remain to be fully understood. The collapse also underscores how interconnected Florida's geology is with its oceans. The state is built on limestone bedrock riddled with caves and voids, the same structures responsible for its famous freshwater springs and, paradoxically, its vulnerability to sinkholes on land. What many had not considered was how this same porous foundation extended offshore, supporting the shallow marine platforms just beyond the beaches. The sudden emergence of sinkholes offshore suggests that the forces undermining Florida's stability are not confined to its neighborhoods and highways, but also extend far beneath the Gulf and Atlantic waters. This realization paints a more complex and concerning picture of the entire peninsula's long-term integrity. Marine scientists observing the event pointed to how fragile coastal ecosystems can be when geological upheavals occur. Coral reefs, already stressed by warming waters and acidification, found themselves shattered by crumbling slopes. Beds of seagrass, vital for manatees and juvenile fish, were torn apart as sediment avalanches cascaded into the holes. The event effectively rewrote the map of local habitats overnight. While the natural world is resilient, such sudden change leaves little time for adaptation. Creatures accustomed to predictable seabed contours suddenly found themselves navigating unstable, shifting terrain. The visual drama of the collapse also tells us something about the raw power beneath the surface. When sediment dropped into the voids, it set off underwater currents strong enough to dislodge anchored objects and scatter them across the seafloor. The shifting of pressure created low-frequency vibrations, detectable even on shore by sensitive instruments. These seismic ripples testified to the scale of the movement, as if the Earth had groaned under the weight of its own instability. Beneath the water, divers and remote submersibles recorded jagged cliffs where flat seabed once stretched. The contrast between the old landscape and the new voids was stark, a reminder that the Earth's foundations are never truly fixed. The implications of Florida's ocean floor collapse reach far beyond the immediate geological disturbance. Shipping routes, fishing grounds, and even coastal infrastructure are tied to assumptions about stable underwater topography. The sudden creation of sinkholes calls those assumptions into question. Navigation charts become outdated in an instant, and vessels that rely on consistent depths face new hazards. Fishermen who know the contours of the seabed by memory must now contend with chasms that could entangle nets or redirect fish populations. For industries built around the sea, the collapse was not just a scientific curiosity, but a direct challenge to livelihoods and safety. This kind of dramatic seabed change also poses risks for tsunamigenic activity, though not in the conventional sense of tectonic earthquakes. When large volumes of sediment suddenly slump into deeper waters, they can displace enough water to generate localized waves. While not always catastrophic, such events highlight how collapses can ripple outward beyond the immediate zone. Florida's coastal communities, accustomed to watching the weather for hurricanes, may now face another natural force demanding attention: sudden reshaping of the sea beneath them. The collapse demonstrated that the threats to coasts are not only atmospheric but also geological, hidden in the substrate below. For scientists, the event opened a new chapter in studying Florida's oceanic environment. Instruments deployed along the seabed will now track how the new sinkholes evolve, whether they expand further, and how marine life responds to them over time. The initial collapse may only be the beginning of a chain reaction. As weakened edges crumble further into the depths, each new fall of rock and sediment reshapes the currents, alters habitats, and deepens the voids. The process is dynamic and its trajectory is uncertain. Yet one thing is clear: the collapse exposed vulnerabilities that were always present, waiting for the right combination of forces to reveal themselves. At its core, this event is a reminder of how alive the Earth beneath the ocean truly is. We often think of the seabed as static, a quiet floor upon which the drama of marine life plays out. In reality, it is restless, constantly shifting in ways both subtle and explosive. Florida's sudden sinkholes embody this restlessness, showing that the same instability that swallows streets inland can just as easily manifest beneath the waves. The collapse is both a geological spectacle and a sobering demonstration of the hidden mechanics of our planet. It forces us to confront the uncomfortable truth that stability is an illusion, whether on land or beneath the sea. The scale of the collapse also carries psychological weight. For residents of Florida, a state defined by its relationship with water, the idea that even the ocean floor itself can collapse challenges perceptions of security. Beaches, reefs, and fishing grounds are woven into the identity of the region. To imagine them suddenly dropping into sinkholes is to imagine the erasure of landmarks that have shaped generations. The event forces a rethinking not only of science and engineering, but also of culture and connection to place. The sinkholes themselves are vast mysteries, beckoning exploration yet resisting full understanding. Within their depths, strange environments will emerge. Deeper layers of rock and water, long isolated, are now exposed to the open ocean. Unique microbial communities may thrive there, adapted to darkness, pressure, and chemical gradients unlike those of the surrounding sea. Just as terrestrial sinkholes sometimes reveal hidden caves and fossils, these oceanic sinkholes may open windows into unseen chapters of Earth's history. In this sense, the collapse is both destructive and revealing, tearing apart ecosystems while unveiling hidden realms. The collapse raises profound questions about human activity's role in accelerating geological change. Offshore drilling, groundwater extraction, and the alteration of natural water flows all put stress on fragile limestone systems. While natural processes undoubtedly played a role, the extent of human influence cannot be dismissed. The balance between fresh and salt water, the pressures exerted by extraction industries, and the cumulative impact of coastal development all weigh upon the subterranean structures. The sinkholes may represent the visible breaking point of pressures that have been building invisibly for decades. Beyond geology, the collapse highlights the vulnerability of Florida's already precarious coastline. Rising seas, intensifying storms, and now unstable seabeds form a triad of challenges that converge on the same communities. Each factor magnifies the others, creating a landscape where unpredictability is the only certainty. The sudden disappearance of seabed terrain into sinkholes becomes a metaphor for the fragility of living in a place where land and water are constantly negotiating boundaries. From a scientific perspective, Florida's ocean floor collapse offers an unprecedented natural laboratory. The newly formed sinkholes are dynamic test sites for studying collapse mechanics, groundwater-ocean interaction, and ecological disruption. Sensors can track how pressure changes ripple through aquifers, how sediment shifts under currents, and how marine life colonizes the new voids. For researchers, the event is both alarming and invaluable. A chance to observe in real-time processes that are usually hidden over vast timescales. Yet the very act of study is fraught with urgency, since the conditions continue to evolve unpredictably. At the human level, the event fuels a mix of awe and unease. There is awe at the raw scale of Earth's forces, which can erase centuries of seabed stability in an instant. But there is also unease at the realization that these forces operate so close to shore, so near to communities that depend on the sea. The collapse is not a distant, abstract phenomenon. It unfolded on Florida's doorstep, in waters that millions swim in, fish in, and gaze upon daily. That intimacy with geological upheaval leaves a lasting impression, a sense of vulnerability that cannot easily be shaken. Even as the collapsed regions settle into their new forms, their story is not finished. The edges of the sinkholes are unstable, likely to crumble further with time and pressure. Currents will reshape them, perhaps widening their mouths or deepening their interiors. Life will return, but in altered forms, as opportunistic species exploit the new terrain. The sinkholes will not remain static scars. They will evolve, becoming part of the ever-changing seascape. In that evolution lies both risk and discovery, as the collapse continues to write itself into the narrative of Florida's relationship with the sea. Florida's ocean floor collapse stands as a reminder that beneath the tranquil waves lies a restless foundation. It demonstrates that sudden change is not limited to storms above the surface, but also to upheavals below. The sinkholes that emerged are monuments to instability, to the hidden fragility of limestone foundations, and to the relentless processes that shape our planet. Their gaping mouths tell us that even the most familiar waters conceal the potential for shock and transformation. For Florida, a place defined by water, that lesson could not be more profound. The collapse of Florida's ocean floor into sudden oceanic sinkholes left behind not only a physical rupture, but also a profound sense of uncertainty about the hidden dynamics shaping coastal regions. While the immediate image of gaping chasms and swirling clouds of sediment is striking, the implications run deeper, branching into disciplines as varied as geology, marine biology, hydrology, engineering, and even philosophy. To continue exploring the scope of this phenomenon, it's important to expand beyond the event itself and consider the many ripples it casts across scientific understanding, ecological systems, and human perception of stability. One of the most compelling aspects of this collapse is the way it draws attention to unseen systems beneath the ocean floor. The limestone that underlies Florida and its offshore platforms is not solid in the sense that granite or basalt might be. It is riddled with ancient channels, voids, and porous layers that act like a sponge. Over time, water moving through this labyrinth of passageways creates weaknesses that may span miles in scale. When the collapse occurred, it was not simply a surface feature giving way, but the exposure of an entire hidden architecture that had been slowly eroding from within. This makes the event a revelation of sorts, exposing the invisible scaffolding upon which Florida rests. From a hydrological perspective, the connection between aquifers and the ocean floor has rarely been so starkly emphasized. The Floridan Aquifer, one of the largest and most heavily relied upon freshwater systems in the United States, lies beneath much of the state. With ocean sinkholes tearing open new conduits, the boundary between freshwater and saltwater becomes far more porous. Saltwater intrusion, already a concern for communities drawing drinking water inland, may accelerate as the equilibrium of pressure between ocean and aquifer shifts. These sinkholes may act like open doors, allowing seawater to push further inland through underground passages that were once blocked or narrowed. The collapse, therefore, represents not only a geological event, but a potential reshaping of water security for millions of people. The collapse also holds lessons about scale and time. Sinkholes on land can seem sudden, but they are typically localized, swallowing a house or a stretch of road. Oceanic sinkholes, by contrast, occur on scales that dwarf human structures, reshaping entire habitats at once. In terms of time, the collapse unfolded in moments, but the preparation for it spanned centuries, perhaps millennia. Water had been dissolving limestone, opening cavities and reducing structural support long before any humans settled Florida. The event, then, is the intersection of slow geological processes and sudden catastrophe. It is a reminder that what feels instantaneous to us is often the culmination of vast, patient forces that we rarely consider. Marine ecosystems respond differently to such upheavals compared to terrestrial ones. On land, a sinkhole often destroys what lies above with little possibility of recovery. Underwater, however, collapse creates new landscapes that can, over time, support life in different forms. The fresh vertical walls of rock may become colonization grounds for corals, sponges, and barnacles. The deep, shaded recesses of the sinkholes may shelter species adapted to low light. Predators might exploit the new topography to hunt more effectively, while prey species might find refuge in cracks and overhangs. In this sense, while the collapse represents destruction, it also plants the seeds of new ecological complexity. The ocean has a way of turning chaos into opportunity, though the process is neither immediate nor predictable. Another striking element of the collapse is how it reorients our understanding of the sea as a boundary. For centuries, coastlines have been thought of as edges, dividing land from water, stability from fluidity. But what happens when even the seafloor itself is unstable? The event blurs that boundary further, suggesting that land and water are not as distinct as they appear. Beneath both lies the same porous limestone, the same vulnerabilities, and the same potential for sudden collapse. The ocean's surface conceals this fragility, but the event exposed the continuity of Florida's geology across land and sea. In this sense, the collapse forces us to think less in terms of divisions and more in terms of interconnected systems. Engineering and human infrastructure face their own set of challenges when events like this occur. Coastal installations, from underwater cables to oil pipelines and communication lines, rely on the predictability of seabed contours. The sudden creation of sinkholes introduces new risks, unsupported spans, shifts in current patterns that may erode foundations, and debris fields that could entangle or sever connections. Even offshore wind projects or tidal energy systems, which are increasingly being proposed in different parts of the world, must consider the potential for such collapses when anchored in geologically vulnerable regions. The Florida sinkholes, then, serve as a cautionary tale, not only for the state itself, but for global coastal development. From a biological and evolutionary standpoint, events like these highlight the adaptability of life. While the immediate effect is destruction, in the long arc of time, such upheavals act as drivers of change. Species that can adapt to new environments, colonize fresh substrates, or exploit altered food chains will thrive. Others may perish, but their absence creates opportunities for diversification. Florida's sinkholes could become sites of rapid ecological experimentation, with novel assemblages of organisms forming within years. These changes provide living laboratories for scientists interested in resilience, adaptation, and the processes by which ecosystems reorganize themselves after disturbance. Philosophically, the collapse challenges notions of permanence. Humans often assume that the ground beneath them, or beneath the ocean, is stable, unchanging except over immense geologic timescales. But events like this collapse puncture that illusion. They remind us that instability is a natural state, and that the apparent calm of the Earth is maintained only through delicate balances. Just as hurricanes reveal the volatility of the atmosphere, sinkholes reveal the volatility of the crust beneath the seas. For people living along coasts, the collapse underscores that security is temporary and conditional. The event also invites comparisons with other places where ocean floors have shown sudden change. In the Caribbean, in the Yucatan, and in parts of the Mediterranean, submarine sinkholes and blue holes punctuate the seabed. These features, often circular and deep, are both geological oddities and ecological hotspots. Florida's new sinkholes may join this family of formations, reshaping the local seascape into something more dramatic and potentially more biologically rich. Each such site becomes a combination of scar and sanctuary, a testament to collapse but also to renewal. From the perspective of human culture, the collapse resonates with myths and stories of land sinking beneath the sea. Legends of lost cities of Atlantis or of coastal civilizations swallowed by water are common across cultures. While the Florida event is not about cities vanishing, it echoes those archetypal fears of the ground itself betraying us. These myths have always carried kernels of truth, grounded in real events of flooding, earthquakes, or subsidence. The sudden emergence of sinkholes offshore adds another modern chapter to this timeless narrative of instability at the margins of land and sea. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Florida's ocean floor collapsing into sudden sinkholes? We want to hear from you. Thank you for watching and see you next time.